Basic trigonometry is something that we will need for statics. And one of the things that we will make use of a lot is the idea of a right triangle. This is a triangle that has one of its corners having an angle of 90 degrees. If we label the sides of this triangle with side A, side B, and side C, where those labels indicate the length of each of those sides, then we can say by the Pythagorean theorem that a squared plus b squared is equal to c squared. We will make use of that formula often. We also can draw a right triangle as follows. And it's not necessarily similar to the first one, but they are look similar. We have that we can label the angle here as theta. We can call this the adjacent side. It's adjacent to where this angle is. The long side of this triangle has a special name. Even though it is adjacent also, it's the long side, and so it's called the hypotenuse. And then we have the opposite side. Now, with that in hand, we can write the following three trigonometric functions. Sine of theta is equal to the opposite length over the hypotenuse length, and the cosine of theta is equal to the adjacent length over the hypotenuse, and the tangent of theta is equal to the opposite length divided by the adjacent length. We will make use of those trigonometric functions often when we are doing statics. And it's very important that we recognize that if we have any two of these quantities, the three quantities being theta, opposite, and hypotenuse, we can solve for the remaining quantity if we have two of them. So, for example, here, if we wanted to know the opposite length of the triangle and we had theta and the hypotenuse, we can rewrite this equation as the hypotenuse length times sine of theta, and that will be equal to the opposite length. We could do similarly that the hypotenuse times the cosine of theta will be equal to the adjacent length. And lastly, here we might say that the adjacent length times tangent of theta is equal to the opposite length. Now, knowing now that we can get any one of these quantities if we have at least two of them, this is a benefit to us when we do statics. For example, let's suppose that we have a coordinate system. Here's the x direction, here's the y direction, and let's suppose that we have a force vector. And we want to know the components of that force vector. That force is acting at an angle to the coordinate system, and maybe it's a 30-degree angle. and maybe this force is 10 pounds. Then if we want to find the x component, Fx, or we want to find the y component of this force, then we can do that by using basic trigonometry. Notice here that this triangle, we've drawn this dashed line perpendicular to the x-axis. So this triangle that makes up the force in the x direction, and even the length that we see over here for the y direction, it makes up a right triangle. And so we can say that this force has a length of 10 pounds. And we could then figure out what Fy is, and we could figure out what Fx is using basic trigonometry. For example, Fx, using the formulas that we found above, we could use this formula, and we would see that Fx is equal to 10, the hypotenuse, times cosine of 30 degrees. And if we were to do that by using our calculator, we would find that we get a value of 8.66, and there are other decimals beyond that as well. Now, in order to do that, we need to make sure to have our calculator in degrees mode. So make sure you have it in degrees mode instead of radians, and then this will work so that you can enter 30 degrees directly into the cosine function on your calculator. Now, the force in the y direction is going to be equal to 10 times the sine of 30 degrees, and this is going to come out to 5. And both of these will be pounds. Well, that gives us a basic introduction to some trigonometry and why we would want to be able to do that in statics. We'll be working with forces a lot, and we'll be needing to find the various components of those forces as we analyze various structures and machines.